All right. Welcome back to United Astronomy Clubs of New Jersey. What's up in the November sky? Take two. Thank you all for have joining us tonight, and many apologies for all the technical difficulties that occurred last week. We still have a few things to sort out with that particular studio setup, but we have actually managed to bring you the program tonight. We should be good on audio issues since we have moved temporarily back into the observatory, even though we do not have public here on site for this for the winter. Uh, so first off, again, welcome. Want to shout out to Miss Yvette, 1998, who followed, and Ariana Celestine, who subscribed. All of these are great ways to help us that help us support our mission here at UACNJ for taking out astronomy and science in general to as many people as we can. With that, you can check us out on our website, uacnj.org. It's where you're going to find a list of not only all of our scheduled upcoming talks, but in it also other information as to what telescopes we have on site, what our member clubs are up to, and also what other science projects might be happening. You can also check us out on our social media pages, our Facebook, our Instagram. We have a Discord server. All great options to get in touch with us, ask questions, share your experiences, your astrophotography. We'd love to see those there. Um, so I don't need to give the safety briefing, and I nearly went into that. We don't need it since you guys are not parking on site, and you aren't here to hear me babble on forever. So tonight's talk is going to be What's Up in the November Sky with Lonny Buinis. Lonny has been giving the What's Up series since UACNJ opened in 1994. He received degrees from Stevens Institute of Technology in physics and computer science, then learned space art and animation and video all on his own. Lonny is the only member of the IAAA who specializes in virtual reality worlds, and he wrote the first interactive space history ebook and is most pleased to have married Jan, his narrator. And with that, here's Lonny.
Thank you very much, Kim. Always great working with you and Chris behind the scenes. It would not be possible to do the series without the dedication of people like Kim and Chris and all the volunteers at UACNJ. I am Lonny, and I'm part of the member of the International Association of Astronomical Artists. That's that IAAA that Kim referred to, and the logo at the bottom of this screen. What's Up in the November Sky is briefly summarized right here on my title slide. On the middle of the month, on the 15th, the moon is full. It's in the constellation Taurus. Some of you know the zodiac signs that line up the sun, the moon, and the planets, like Jupiter, the moon, the planet Uranus, the planet Neptune, the planet Saturn. They all line up in a straight line through the zodiac signs. Aquarius, the water carrier, Pisces, the fishes, Aries, the ram, looks just like a ram, right? I can feel you all nodding furiously. And the bull, Taurus. And these line up the solar system in a nice line because the solar system, the major planets of which are pretty much in a flat plane. The Earth's orbit drawn out into space would line up along these constellations. Let's take a more in-depth look. And I'm going to look at some events for this month. I like to get my information from a couple of sites, Go-Astronomy, starwalk.space. The websites that you see me quoting in tonight's talk, I don't work for any of them. I am an amateur astronomer. I do this for love, not money. And also, before I go on, I do want to give a special recognition to our friend Joe, who was looking forward to the talk last week when we had some technical difficulties. I'm glad that, Joe, you made it back again, as I'm glad that everyone else has too. Thank you. So let's take a look at Starwalk's site. You can find their astronomy news, a calendar of events. And for this month, we've got some past events that I've grayed out. And I'm looking forward to things like the moon coming near the planet Saturn, phases of the moon, a good time to see the innermost planet, Mercury, close to the sun, and a minor meteor shower. Let's start with phases of the moon. Every month, the moon is close to the sun in the daytime sky. We call it new. And every month, half a month later, this month on the 15th, it's not only full, but a supermoon. We're going to explain what that means just a bit. So phases of the moon, you can get a lot of information on the moon at a site called Moon Giant. Why did they call it moongiant.com? I don't know. Look it up. But you can see the current phase of the moon. If you go outside tonight, or if you did do that at sunset, the moon would be due south in quarter phase, a quarter of the moon that we can see lit. But we know that half the moon is lit up at all times because it's a ball, it's a sphere. Where's the other lit part? It's on the side we don't see. The moon always faces us in one direction because its rotation around its north-south axis is frozen to be the same as its revolution around the Earth every 27 1/3 days. It's a synchronous rotation. Turns out that all the major moons of the solar system do this with their parent planets. The big moons of Jupiter, the big moons of Saturn and Uranus and Neptune. They've all got this locked or synchronous rotation. So nice quarter phase. That's a good time to see details here by the shadow, right, between the terminator, the boundary between light and dark. When I looked at the moon for the first time in my first telescope, I saw lights on the dark side of the moon near the terminator. I thought they looked like cities, but what do you think they were? Think about it. We'll come back to that. Moon Giant also has terrific calendars. I've got both the northern hemisphere and the southern hemisphere. Note the difference, except for the full moon on the 15th, which looks the same anywhere on Earth. So a good time to see faint objects in the sky is when the moon is close to new in the daytime sky. Close to the sun, it doesn't interfere with the viewing at night. Worst time to see either faint objects at night, like gas clouds where stars are born, or clusters of stars, is when the moon is full. And you can't even see detail on the moon. No shadows, right? When you hold the light behind you and shine it on something directly in front of you, there are no shadows. So there's no relief, no shadows to see no detail. So terrible time to look at the moon is when it's full. When I got my first telescope, that's when I looked at the moon and I thought, how disappointing. Try it on different times. You can highlight the phases of the moon. Turns out next month in December, they all line up pretty much on the same day each week. That happens every once in a while. Moon Giant, very nice calendar. Every full moon has a poetic name given to it by the Boy Scouts and Native Americans. And there are many names each month. One of the most popular is the Beaver Moon, when the beavers are out in November preparing for the winter. This one is a super moon, so we call it the Super Beaver Moon. But I found 10 names for the full moon. And a really nice long one is Moon When the Rivers Begin to Freeze. Or a very practical name, you can see where it came from. Moon of Moving Inside for Winter. Heading to Winter Moon. Nice short one, Frost Moon, Turkey Moon, Panther Moon. But the Beaver Moon is a standard. Why is it a supermoon? Because the moon does not revolve around the Earth in a circle. It's not a perfect circle. It's a squashed circle. Mathematicians call it an ellipse, and it's not as squashed as you see in this picture. That's a big exaggeration. But there are differences in the distance, and here they are to scale. When the moon is away from the Earth, away at apogee, it's at its greatest distance. Average distance is about 250,000 miles, or 400,000 kilometers. Perigee, P, pretty close. A for away, P for pretty close. Compare the two, and you see that there's not a whole lot of difference even between the minimum size for the moon and the maximum. And it's also only about 30% brighter than a small micromoon. So when you read an article that says, the moon, don't miss the supermoon, it'll be larger than it's ever been in a month or two, it's nothing to get excited about. You can see this series of pictures I just showed you as an animation on YouTube. We've got a meteor shower coming after the middle of the month. Unfortunately, the moon is still close to full in gibbous phase. It's on the wane going towards the sun in the morning sky. So it's waning gibbous, very slightly dark on the right side. And that will interfere with the Leonid meteor shower from Leo, the lion, coming from Leo. But it might be worth a try. You might see one, not 15 per hour. Depends on how dark your skies are. These are unusually fast meteors, like more than 3 times faster than typical, 70 kilometers per second. Multiply that by 3,600 to get kilometers per hour, and divide by 1.609 to get miles. In other words, fast. Thousands of miles per second, not hour. The peak is November 17th, but if you miss that, or if it's cloudy or hazy, try up until early December. What do you have to do to see a meteor shower? What are the best pieces of equipment? What procedures should I do? Well, you want a comfy chair. You can buy a 1/6 scale replica of this one for only $130. Again, I don't work for this company. Just kidding. How about a comfy lawn chair would be better? You can get a vintage one from 1970, still available on eBay and online. That's about the best. I think that's one of the best pieces of equipment. Lie back and use your entire vision to cover the whole sky where the meteors show up. So you're going to need a couple of these. They don't cost $22. You have them already in your head. And you can use them to look on the 11th, only 2 days from now, when the moon is near the planet Saturn. Now, on part of the Earth, there's an occultation of Saturn by the moon, lunar occultation. What does that mean, occultation? Sounds like something that maybe a shaver does. No, maybe that's something that Halloween witches would incant around a fire. Nope, occult means hide or hidden. And unfortunately for us, this occurs in a very narrow path over the Earth, mostly towards South America. So this is the best we're going to see at 22 hours. For those of you who are not familiar with with military time, subtract 12 from 22 to get. I don't hear anybody. Nothing in chat. 10 p.m. Can you stay up till 10? That's the minimum distance approximately of Saturn from the moon. Saturn being a whole lot smaller than the moon. This is the way Saturn might look in a small telescope at a magnification around 60 times, 70 times, something like that. And I see some bright moons. In small telescopes, you can see up to 6 moons of Saturn, including Titan, the giant reddish moon covered with a methane atmosphere that makes it look red. Rings of Saturn are going to close up entirely and disappear next March. As Saturn moves around the sun and we move around the sun, we catch up with the plane of the rings, and they tilt up and down over a period of 29 years that it takes Saturn to go around the sun, as opposed to the Earth's 1 year. So why don't we simulate how some of these events will look with some alignments of the moon and planets, and a quick look at the nearest planet to the sun, Mercury, which is elongated away from the sun to the east. Now imagine yourself facing south, and we're going to do this with a free program called Stellarium. And you can install it, you can download it, you can run it off a website. Whoops, I'll tell you about that later. Or you can put it on a mobile device. Well, there's where you're going to be looking for the planet Mercury on the 16th. November 16th at 17 hours minus 12 equals. Yeah, early, 5 p.m. It might still be light, too light to see the planet Mercury. Very close to the horizon. If, like me, you have houses and trees in the way, you might not see it at all. But last night, I did see the bright planet Venus near the Centaur, half man, half horse, holding bow and arrow. Here's the outline of stars. Looks just like a centaur holding a bow and arrow, right? No? We amateur astronomers call it the spout, lid, and handle of the teapot, Sagittarius. So the stars might be hard to see, but the bright planet Venus is unmistakable. What does it look like in a telescope or pair of binoculars? Gibbous phase, like the moon sometimes. Venus is featureless in optical telescopes. Can't see a thing. The bright clouds hide everything. Can't even see these faint markings here in this photo made with a space probe. Venus, similar in size to the Earth, but very different on the surface. That's where you're going to find the planet Mercury, close to Venus. Mercury also goes through phases. Galileo saw this 400 years ago and drew phases on the inner planets, and thus he realized that they orbited the sun, not the Earth, going through phases like the moon. Good way to get oriented looking at the sky is to use a star chart. We happen to sell them at UACNJ, Jenny Jump. They look like a circular map that you can spin around the North Star, where the North Pole points, to see the sky for any time of day or night, or any time of the year. But in a computer program, I can move around. I can zoom way in to see a more realistic sky, not at 5 p.m. or 6, but maybe 7 or 8 would be a nice dark sky. And what you want to do is run outside and look for the letter N to face north, correct? Wrong. You want to look for Polaris, the pole star. And how would you find it? Well, if you live where there are a lot of high trees and houses, you might not see the Big Dipper at all this time of year. Big Dipper, part of the Great Bear, head claws, Ursa Major, which point 5 times the distance between the pointer stars in the bottom, the front of the bowl of the Big Dipper. 1, 2, 3, 4, 5. You'll come to the North Pole, which is marked by a tiny little blue X, right? Right? Will you see that in the real sky? No. The pole star is pretty close to where the Earth's axis points. In the southern hemisphere, unfortunately, they don't have a bright star. And in fact, over the entire 25,000-year cycle that the Earth precesses or wobbles like a top, they won't have any bright star very, very close to the south celestial pole. We have the north celestial pole here. It's very close to Polaris right now. And for the next few hundred years, that's our pole star. So you can find north pretty easily by looking for the Big Dipper or the Little Dipper. Unfortunately, where I live, there's a lot of light pollution. I see the North Star. I can barely see these two stars, and sometimes I can't see them at all. But I can see north, and I can see the North Pole Star. And I use a compass. I cheat. There are stars that never rise or set, but just spin around the North Pole. from New Jersey, and those are the stars of the dragon, Draco, the king, Cepheus, the queen, Cassiopeia, and the big and little dippers, part of the great and small pairs, Ursa Minor, small. So once you've got yourself oriented to north, spin towards the west to see the planets Mercury and Venus setting. By 8 o'clock at night, they're gone. They've set. As the Earth rotates, the Earth rotates this way, the stars go that way. The whole sky seems to spin very slowly. You can see some of the summer stars disappearing. The summer triangle stars, Vega, Deneb, and Altair. I talked about those in past What's Up talks. Those will be disappearing in the west. And close to Christmas, the swan, Cygnus, is close to the horizon. So in the past has sometimes been called the Christmas cross. But we're going to be looking for other stars to be going. The stars of late autumn, the giant square, called unimaginatively by astronomers, I think, the Great Square, which in real life is so big you have to turn your head side to side to see the whole thing. And you have to turn your head to see Andromeda, the princess. Not too many stars making a princess here, but they help us find the Andromeda galaxy, which I talked about in past What's Up talks. See if you can find it. You need a dark sky. Instead, this time of the year, we have high in the south, the fishes, Pisces, the ram, Aries looks just like a ram, right? You can cheat a little bit in Stellarium. You can put up images from many cultures, dozens of cultures. These are the standard, some of which came from ancient Greek mythology, but you're not stuck with those. And finally, the winter signs are coming up. Orion the Hunter is low 8 o'clock at night. The bull is coming up with 2 star clusters in the bull. The old Hyades star cluster, group of stars born close together, clustering together, moving together through space. And recently discovered the Pleiades, the 7 sisters, which actually consist of dozens of stars. We generally see 6 or 7, depending on how sharp your eyesight is. We think now that this gas that we used to think they were born in, it might just be that the cluster is moving through it accidentally. Why does the gas look blue and gaseous, nebulous? It's a nebula. So called the reflection nebula because it's reflecting the light of these hot, young blue stars. They're going to burn out in no time. They use their nuclear fuel so fast, they're gone in a fraction of the age of the sun. The sun's been around for 5,000 million years, 5 billion years. It'll be around another 5 before it changes. These stars will vanish within a few 100 million years, a tiny fraction of a billion. But see if you can see 6 or 7 stars in the 7 sisters. Some people mistake them for a little dipper. We have the chariot rider nearby, Auriga, with the bright star Capella. You can click on things to get information about them in computer programs like Stellarium. You can zoom in on things like planets. Now, you'll notice in this area, terrible night for viewing faint stuff, by the way, with the full moon. I've blown it up a little bit. That's 3 times its normal size. You should be able to just make out this little sea, Mare Crisium, the Sea of Crises, with the naked eye, just barely visible. Right? It's about twice the size of New Jersey. It's a frozen lava sea, just like these others. There are very few on the other side of the moon. Well, right nearby is the planet Jupiter this month, looking fairly bright. You can't mistake it. It's very high in the sky late at night. In a small telescope, you can see a couple of bands cloud bands, each wider than the planet Earth, 8,000 miles across. You can see the 4 satellites of Jupiter discovered in 1610 by Galileo. And in larger telescopes, you can see a lot of detail on Jupiter. If you come visit us April through October, I'll show you what things look like through some of the telescopes in the 6 observatories. In much bigger telescopes, Jupiter shows incredible detail. We've learned a lot about atmospheres by studying Jupiters. One of the most fascinating moons of Jupiter is the smallest and brightest. Smallest yet brightest. That sounds impossible, but it's bright because it's covered with an icy shell, cracked by the pull of Jupiter with its tidal forces on Europa. We believe there's an ocean of water in there with organic compounds, carbon compounds that could lead to not only primitive life, but advanced life. Maybe, is there animal life swimming in the oceans of Europa? We may find out within our lifetimes. NASA has a planned mission to orbit Europa, the Clipper mission. Check it out. Come to any observatory that's open, or check with your local amateur astronomer. You might see him or her out on a night on the street or in the backyard, checking out the sky. We can come back to the sky for questions later, but I just want to see if I've missed anything. If I look up very high in the sky, I will see Perseus, the hero of legend. Perseus, who rescued Andromeda by using the head of Medusa, and there's her eye, a head of snakes. If you looked into the eyes of Medusa, you would turn to stone. I don't want to ruin the story. Go find out how Perseus saved Andromeda. This star, Beta Persei, Beta P-E-R, astronomers like to shortcut or abbreviate the constellations with 3 letters. So Ursa Major is Uma, Perseus is Per, and the second brightest star is Beta after Alpha. It's an eclipsing binary, 2 stars that eclipse each other, causing the star to blink every few days. And you can see that, you can watch that happen, even with a small telescope or binoculars or the eye. I'll be talking more about the winter constellations in What's Up in December. You guessed it, December, the next month. Orion, Gemini, and the dogs. Let's see, do we have a lot of time? Yeah, we do have some time. You know, what I did not look at is other planets that are in the sky and some deep sky objects, DSOs, no relation to UFOs. As a challenge, I've been using my telescope for the first time in years. I've been trying to see disks of all of the giant planets that are all out into night sky: Jupiter, Saturn, Uranus, Neptune. But even in powerful telescopes, Uranus usually shows a featureless disk. Some early optical observers noticed a white equatorial band, but it was difficult because it's closer to the limb, the edge of Uranus. Uranus is tipped 98 degrees over and orbits backwards. Something big hit Uranus in its early history. Even with telescopes far away on Earth, long ago, before we had robots going past the planets, including Uranus, observers noticed a brightening equatorial band. They did not see the rings that had to be discovered many years later. They did see 5 bright moons, or 4 bright moons. Miranda, the inner one, is not as bright as Ariel, Umbriel, Titania, and Oberon, all named for characters from William Shakespeare plays. The other 2 giants that are out are Neptune and Saturn. Neptune's a difficult object to find. Not for me, because I've got this program. Of course, I didn't hit the right object. Looks like a blue star. So far, all I've seen of these are star-like points for Neptune and Uranus. Got to use a lot of magnification to see a disk. And again, Not much detail. Maybe a white equatorial band. The dark spot has come and gone, discovered by Voyager 1989. One big bright moon, Triton, about the size of Pluto, orbiting backwards, clockwise around Neptune. Not like every other moon in the solar system, every other major moon. There are lots of minor moons that have weird orbits. And finally, if you miss anything else in the night sky this season, look for the planet Saturn. It's getting lower and lower, earlier and earlier. So you want to look for it early in the southwest. Let's blow it up. Small telescope, you'll see the rings. Bigger telescopes show gaps in the rings. There are actually thousands of gaps. But the biggest one was discovered by an astronomer named Cassini. So it's Cassini's division. An astronomer named Encke found Encke's division. And again, I'm reminding you to look for the rings of Saturn because they're going to disappear completely in March. Why? Because they're very thin, thousands of miles across, only 30 feet thick, about 10 meters. Saturn has the highest count of moons. I think the last count, what was it, 165? Might be more by now. Jupiter 95, Saturn 160 something, maybe more. Check out Wikipedia. The count is just going up every year. That's our night sky, simulated in stellarium. I've got a few other tidbits of information for you. One other event, we're waiting and waiting for T Corona Borealis to blow up. And it's actually not the giant red star in this binary star. A red giant, a tiny white dwarf the size of Earth, invisible in this picture, but drawing in material from the red giant into a disk of gas that accretes around the system, called an accretion disk. It orbits every 228 days. It's pretty close, half the Earth-Sun distance. And normally, this star is magnitude plus 10. It's visible in a small telescope, just barely. But every so often, every 80 years, it brightens over 600 times, no, about 1,000 times, to magnitude plus 2, visible to the naked eye. We can see generally down to magnitude 5, or in very dark skies, 6. Each step is multiplied by 2.5118. Right? So every 5 steps is 100. So that's, for you mathematicians out there, that's the 5th root of 100. 100 to the 1/5 power. Yeah, strange. It's a strange scale, a logarithmic scale. But back in 1938, 1946, this system brightened and dimmed and brightened again. Similar thing happened in 2018 and 2023. And that's why we predicted, astronomers predicted, that sometime between April and September this year, the star would blow. Hasn't happened yet. We're anxiously awaiting that. Now, if this had happened over the summer, Corona Borealis would be next to Hercules, high in the sky, as I mentioned in What's Up in the August sky. But unfortunately, this time of the year, T Corona Borealis is in the daytime sky. It's high in the sky at noon. So we're going to have to rely on professional astronomers to find it near the star Epsilon here, forming a right triangle with 2 stars in the crown. Once it brightens, it will disfigure the crown to form an 8th star. 1, 2, 3, 4, 5, 6, 7, 8. Hasn't happened yet. Everybody's anxiously awaiting. Maybe we can send out a message to Mother Nature to hurry it along a little. Check the news. The major news media will certainly mention this if it turns into a nova for about 5 seconds. So you'll probably miss it. To get started in astronomy, the price of giant binoculars has come way down over the years. It competes with the price of a beginner telescope. And it's very easy to use both eyes, less of a strain to look at things with both eyes. The challenge is keeping them steady, like using the roof of a car or some railings that you might want to invest in a tripod. To get started with telescopes, the first scope by Stellestron is very economical. It's alt-azimuth design, altitude azimuth. You have to keep pace with objects as they move across the sky, but it's a good way to get started. And so I've just put up a sampling of different kinds of instruments. Reflector uses a mirror on the bottom. Refractor uses a lens at the top. Two different styles of telescope. And if you need more light, some of you want to look at faint stuff. If you spend a bit more money, a lot more money, I admit, you can do that for the best bang for the buck with a Dobsonian design telescope named after a man named Dobson. So it's an eponymous name. It means it comes from the person. 8-inch or 10-inch Dobsonians collect a lot more light than most beginner telescopes. United Astronomy Clubs of New Jersey. Repeat after me, UACNUJ. Yep, I don't hear anyone. It's because I can't. UACNUJ.org is our website. It's an umbrella organization of different astronomy groups, mostly in New Jersey, some in Pennsylvania and New York. If you like to read, does anyone still like to read out there? You can respond in the chat. I'd like to know. Any readers? Raise your hand. Can't see your hand. Sky and Telescope, astronomy. They've been out there for decades. They have wonderful subscription websites, superb information, but a lot of that stuff on the website is free. No charge at all. Check it out. And space.com is easy to remember with its news, science, search for life, and forums where you can communicate. You can communicate with UACNJ as well from many different fora. I will show those at the end. Space.com does have an article on best stargazing apps. I have an Android phone, so I was able to find 21 night sky apps, but they all have different uses. Like Sky Safari 7 is best overall, maybe a little bit more difficult to use for beginners. Best beginner might be Starwalk 2. I like Stellarium, the program I was using to show you the sky, to simulate it. Comes in a mobile version, and I use it because I can't tell what I'm looking at in this hazy sky. I hold my phone up, I point it at Auriga the Chariot Rider, and it shows me Capella. It actually puts the name of the star up, and I can tell, oh yeah, that's Capella. I need that to align my telescope. Best for entertainment, best for information, best free, best for Apple users, Night Sky 11. So there's a nice article on the best stargazing apps. There's actually several. They listed 10. I'm just showing you 9 here. Here's what Stellarium-Web looks like if you don't like to download anything, or if you don't want to use a mobile device on a computer. What's that, a computer? Do we call it a computer anymore? Computor. Wouldn't it be more accurate to call it a digital assistant? You can just use the supercomputers at Stellarium-Web to simulate the sky the way I did. And then on your phone or tablet, Stellarium Mobile is free. I like Celestia at celestiaproject.space, but you can just search on Celestia and astronomy. You can fly to other planets and see what they look like from their moons. For instance, there are only 2 places, 2 pieces of ground where you can see the rings of Saturn open. One of them is a moon that has an orbit tipped to Saturn's equator. So every 79 days, it goes all the way around, and it cycles through the rings of Saturn. They disappear as a thin line. They open up again beautifully. That's the moon Iapetus. Author Arthur C. Clarke once wrote that this would be a great place to put a hotel. So I'm writing a science fiction story about what goes wrong when you try to install a hotel on Iapetus. Celestia, check it out, it's really cool. A quick review for those of you who weren't taking notes. You know, at the very least, you could just take a picture of my screen with your phone, right? That's a new way of taking notes. The lazy person's approach. You want to see lazy, go watch the movie Wall-E, Disney Pixar movie, Wall-E. Shows you what would happen if we just let machines do everything. So November 11th, the moon is near Saturn. Don't miss that very nice conjunction. C-O-N, con means together, with, conjunction, close together. We will not see an occultation. The supermoon on the 15th, bigger, brighter, so bright it'll be blinding. You'll be able to see. No, wrong. Just a little bit, 30% brighter. Look for the planet Mercury on the 16th. When? East of the sun means facing south and west. It's left of the sun. And finally, the meteor shower, you can try. Where I live, it's hopeless. Uranus opposition means it's in a straight line with Earth and Sun. Sun, Earth, Uranus. 19 Earth-Sun distances away. Wow. But all month it will be brightest because it's in opposition. The moon passes Jupiter and Mars. I didn't even show you the planet Mars if you stay up late. T Corona Borealis, when? Nobody knows. No way to predict. Watch, look for it if you can. Well, it's in the daytime sky. That's going to be tough. I said that I didn't look for Mars. Why don't we try that? When? Where is it? Well, I'm going to be looking to the east. Should be rising after Jupiter. 8 o'clock, 9 o'clock, 10 o'clock. There it is. Do you see it? But it's going to be coming through a lot of haze, a lot of atmosphere. The more atmosphere you're looking through close to the horizon, the worse the view. The atmosphere distorts. It causes stars to twinkle, distorts light paths. It generally doesn't make planets twinkle, however. So if you stay up till 11 o'clock, maybe some of you can ask your parents, show me the planet Mars, 11 or midnight. I'm going to zoom in and use a high-powered microscope. Yikes. Telescope. Tele means far, micro means small. I would see in a small telescope an orangey desert-colored disk, a faint white cap, an ice cap made not from water, but frozen carbon dioxide, and some dark markings, volcanic rock that's not covered by the orange dust. I'm going to track Saturn so you'll see some marks around it. Because if I don't track Saturn, it's going to move out of the field of view eventually. Let's see, if I resume time, real time, let me show you what happens. Yeah, in a telescope, stuff moves out eventually, slowly. Telescope view. Whoops. Oops, I can't find it. Where is it? There it is. Not that. Yeah, so if you don't have a clock drive to keep things in motion, many modern telescopes have a computer following the motion of Mars. That's what it looks like in giant telescopes. And some amateur astronomers have gotten some really great pictures by special processing with electronic CCD cameras. Lots of stuff to see in the November sky. I want to thank you for being such a good audience. Before we go, this month, the anniversary of the confirmation of the existence of cosmic rays. And you can find me here at astronomyinmotion.com, Astronomy in Motion, where you can play with 3D objects with your fingers or any pointing device. These are called virtual reality objects. Mars at your fingertips. I actually sell a high-res 4K model of Mars that you can turn. You can click on video links, short, snappy videos narrated by my wife, Jan. Nobody else has anything quite like that. But if you don't want to buy it, you can try it for free. The HD version is free at Mars at your fingertips. That's my wife's hand, by the way, right there. And that's a hotspot. You can find Mercury at Astronomy in Motion, and the moon and all the landing sites. Lots to see here. Even great. This is where you can find United Astronomy Clubs of New Jersey. Do come and visit us online and all these places. And with that, I want to thank Chris and Kim for making this presentation possible, and all of the dedicated amateur astronomers at UWACNIDGE.
Thank you, Lonnie, for another great presentation, and thank you all for joining us. So, I noticed a number of people had some questions in chat, so we're going to get into those since you already covered the social media. First off, Jan says, make sure that you have said hi to her student Joe. So, hi, Joe.
I did toward the beginning, but I want to say I want to thank Joe for tuning in because so it was a little disappointing we couldn't do it on the first of the month, but the UACNJ tech people, some of which are in attendance right now, worked very hard to make it possible to do it now.
Yeah,
Thank you,
occasionally
Joe.
the gremlins are a little bit too much. All right. So, there were a couple questions about the smoke up here from the brush fires and if we are okay, because it seems that every day there's at least one new brush fire in New Jersey. We are currently okay, and we are crossing our fingers that we stay that way. Uh, do keep in mind there are burn bans across New Jersey, so be very careful. No open burning. If you smoke, please be mindful that we can't just be like flicking cigarette ash out of the cars and whatnot, and that we are fully extinguishing those cigarette butts. Not that smoking is allowed in a state park, but it happens, unfortunately. So do try and be mindful that we do not end up just uh, flambéed up here on the mountain. I was trying to think of the correct cooking term there. And I think flambe is the one where it has all the fire. So, all right. Chris also wanted to point out we have 7 observatories, not 6.
Oh, very good.
Yeah, we have Greenwood, Barker, Brady, Bunis, Waldron, uh, and 2 others. 2 club observatories, of which I forget which clubs have them, but we have them, and that is listed on our website. All right, so the first question we actually have is, when we discover exoplanets, we give them a name and number, much like the stars. What happens when / if we contact life on that planet and they have a different name for their planet or star?
Oh, I think that we would respect aliens' right to be called by whatever they want to be called. That's my intuition. Be very exciting to discover life, intelligent life other than our own. It's far more likely that we'll find within our lifetimes that we'll find life that evolved independently of us in our own solar system. But we can always hope that we'll be contacted by extraterrestrials.
The better question is, what if you find 2 of them and they both have conflicting names for
Oh no.
everything for the same object?
We'll
So,
have to call them Bob 1 and Bob 2.
oh, it's like when there's multiple Kims in a class. Okay, you're quiet Kim, you're talkative Kim.
Yep, yep.
All right. So the next question is, what telescope do you happen to be using, Lonnie?
I am using a Maksutov design, which has both a mirror and a lens, a correcting lens in front. It compacts the focal length of the mirror way down from 1.1 1/4 meters down to, oh, you can't see me holding my hands. And I can't show you the instrument tonight, but maybe some other time, to about a couple feet long. It's a 90 millimeters or 3.5 inch mirror, and it's made by a company called Meade, Meade. You can go look that up. It's a Meade ETX 90.
I don't have, I know someone donated one. I don't think we have that available so I could be like holding it up. I think that is firmly away in locked storage.
Ah,
So unfortunately, I can't access that. Otherwise, I would be like, this one, this one here.
Well, all right, next, I'll have that ready for next time.
All right. So our next online question. Uh, isn't it harder to find objects with binoculars because you don't realize how much you actually just move your body and can't stay still?
Oh, you bet. I had a devil of a time looking at the comet recently, Atlas and the Shinshin comet, otherwise known as C20 2023 A3. I did find it in Russian binoculars, 20 power, 60 millimeter lenses. That's 2.4 inches. But holding it steady was difficult. So I actually used a railing on our front porch. And I found the comet. Then I rushed out. I got my telescope. I set it up. And for the life of me, I could not find find the comet in the telescope's viewfinder. No way. It was way too much haze. It was only barely visible against the twilight haze. So yeah, that is a problem, holding it steady. That's why you need some kind of support. A tripod is good. They do make scissor tripods that you can move. It'll stay on the comet no matter how high or low you hold the binoculars. Pretty cool.
Hmm.
All kinds of technologies.
All right. Uh, if you guys have any more questions online, do get those in. I want to make sure you guys have a chance to ask them, mostly because by the time you hear this, we're on to the next thing, and I want to, stream delay's a thing, and we got to make sure you have that opportunity. Welcome in. A couple people had joined us just now. Uh, let's see. The next question is, what is the difference between a computer and a supercomputer?
Oh, it's a distinction that changes with time. For instance, I have a very fast laptop that when I first started doing animation in the 1990s would have been considered a supercomputer because it has 8 cores on a single die. So it's like having 8 computers. It's got a lot of memory. I started with a computer that had 4 megabytes of RAM. A megabyte is 1,024th of a gigabyte, and it ran at a clock speed of 33 megahertz, not giga, mega. In other words, it was really slow. I used 16 of those to simulate a fleet of spaceships flying over a planet, uh, and it took 22 hours for those 16 machines to create the animation. I could do all that in less than an hour now on this machine. Probably actually almost real time. It's so fast. So what's a supercomputer? Well, what they do is they network a bunch of very fast computers together. So the current record holders are into the petabytes of memory. That's thousands of terabytes. It's hard to envision, right? A gigabyte is there's a 1,024 gigabytes to a terabyte. And we're talking about many terabytes. So they use these networks that take a lot of electricity, a lot of power in the thousands, and they can do these wonderful simulations of gravity showing how the moon might have been created by something colliding with the Earth billions of years ago. We couldn't do that as recently as 30 years ago.
Yeah,
I
I
say
believe.
I say recently because I'm old. I know what I was around 30 years ago.
Yeah, I believe they said the common comparison is we have more computing power in our modern cell phones or like smart devices like our smart watches
Yep.
than we did for getting people to the moon the
Oh yeah.
first time. So if that gives you any idea. And back then the computing power was the size of an entire building and or room, and now it's
Right.
fits comfortably on your on your arm.
All
So
of the
that's
most distant, all of the most distant space probes out there, the Voyagers, the Pioneers, even the modern probes are sent with older technology that's hardened against radiation. So the technology in your smartphone is probably better than all of the technology that we've ever sent in robots to the planets and stars?
I don't
That's a good
know.
question.
I think I keep my stuff's a bit older. I tend to repurpose and reuse the older stuff. So
I
perhaps
do
not
too.
my stuff, but people in general, yes.
Yeah, I like to make older things work. I still have my grandmother's push button telephone, has 12 buttons on it. I know what each one does. There's no menus.
All right. So it looks like I don't have any more questions right now. Um, so I do want to thank you, Lonnie, for another great talk. And also thank you all for joining us here online. Uh, so we are going to be, I don't think we have anything scheduled as far as a live talk for the rest of November. I will probably put up some reruns on Saturday. Uh, Whether we will or not, that'll get posted on the website, uacnj.org. Also, keep an eye on our social medias. Like I said, the Facebook, Instagram, our Discord server, all great places to find out information about us and our member clubs. Um, but yeah, so uh, don't forget, guys, do hit those like and subscribe buttons. They're great free ways to show your support for our efforts for outreach and bringing science and astronomy to everyone that we can. Uh, and if you feel extra generous, we are a nonprofit, so all any monetary donations or whatnot do help go to help paying the bills, making sure we can continue offering free outreach, and we do greatly appreciate those. Uh, with that, it does look like I've come to the end of the questions. So I wish you all a great night, clear skies, and good seeing.
Good night.